There is an AI chip orbiting the Earth right now. The same Nvidia chip that every AI company is fighting over is circling the planet as you watch this. And shortly after it got up there, it did something no machine has ever done before. It ran a real AI model in space, fully powered by the sun. The first artificial intelligence ever to think from orbit, running on a chip the size of a textbook, hundreds of miles above your head. And this isn't one strange startup experiment. Google is preparing to send its own AI chips into orbit. Jeff Bezos says entire data centers will be floating in space within a decade or so, and other tech billionaires are quietly making the same bet. Data centers are the neediest buildings we make. They want constant power, constant cooling, and engineers who can walk over and fix things. Space is the most hostile place we have ever put anything, so the question now remains, why are the most practical companies on Earth trying to move their warehouses off the planet? And the answer for that is because it says less about space than it does about Earth. And to see it, you need one mental model, and it's simple enough that you can draw it on a napkin. A data center is a machine that does exactly two things. It pulls it pulls electricity in and it pushes waste heat out. So it's power in and heat out. Every data center decision ever made is where to build, how big, what it costs, and comes down to those two pipes. And here's the key. Earth and space fail on opposite pipes. On Earth, the broken pipe is power in. I've actually covered this topic before on this channel, so if you want to check that out. The grid cannot keep up. In major American hubs, new data centers now wait 4 to 7 years just for permission to plug in. Transformers are back ordered for half a decade, and communities from Illinois to Indiana are fighting these projects town by town. The machines are ready, the electricity isn't. Now, if you look up in the orbit, Google is targeting a pad called Dawn Dusk Sun Synchronous, which rides the line between night and day, so the sun never sets on you. A solar panel can be up to 8 times more productive than the same panel on Earth. There's no clouds, there's no nights, no atmosphere in the way, no county commission meeting. Google's own research paper describes satellites bedded in near constant sunlight, collecting energy almost every hour of every single day. So, space, in other words, has the best power in pipe in the solar system. The sun is a fusion reactor putting out more energy in a second than humanity has used in its entire history. And in the right orbit, you can drink from it continuously. So the pitch writes itself: escape the queue, escape the permits, escape the neighbors, plug straight into the sun. StarCloud's roadmap calls for a 5 gigawatt orbital data center with solar and cooling arrays roughly 4 kilometers across, about the length of Central Park, floating in formation. In February 2026, the company filed a proposal with the FCC for a constellation of up to 88,000 satellites, several times more than every active satellite circling Earth today combined. Google's design envisions clusters of 81 satellites flying just 100 to 200 meters apart, linked by lasers into one giant computer. But remember the napkin we've been talking about. There are two pipes to this. And here's where an honest explainer has to flip the picture, because space has the best power in pipe and it has the worst heat out pipe imaginable. On Earth, we cool data centers with air and water. Convection carries the heat away. In space, there is no air, nothing flows, and as one analysis put it plainly, all heat must be removed through radiators, giant panels that glow the heat away into vacuum, the slowest and heaviest way to cool anything. At high power levels, radiators can account for more than 40% of a space power system's entire mass. Nearly half of what you launch launched just to throw heat overboard. And when something breaks, and in a warehouse of thousands of servers something always breaks, there is no technician. Repairs require robotic servicing missions, which are, in the analyst's diplomatic phrasing, costly and very complex. Add to that radiation slowly chewing through your chips, debris, and solar storms, and you start to understand why this hasn't been done before. So now the question remains, which pipe wins? That comes down to a single number, and Google, to its credit, published it. The whole idea lives or dies on launch costs. Google's analysis found that if launch prices fall below roughly $200 per kilogram, which they project could happen by the mid 2030s, the cost of launching and running a space data center becomes roughly comparable to the reported energy costs of an equivalent terrestrial data center. Today, launches cost several times that. The entire orbital dream is a bet on one curve that rockets, mostly Starship, keep getting cheaper faster than Earth's grid gets fixed. Even the radiation question got a real answer. Google bombarded its TPUs in a particle accelerator and they survived nearly three times the expected 5-year mission those before showing irregularities. The chips are tougher than anyone expected. The economics are still the open question, and now here's the reframe this whole story has been building to, because I would argue this was never really a story about space. Think about what it actually means that this is on the table. The richest, most pragmatic engineering organizations in history looked at building data centers on Earth with its free air cooling, its breathable atmosphere, its repair crews who can drive to work, and concluded that 7-year grid queue, the 5-year transformer backlog, the town halls, and the lawsuits had become such an immovable wall that leaving the planet deserves serious budget. Orbital data centers are not an ambition, they are a confession. When a company would rather engineer around the vacuum of space than around a county permitting process, that tells you exactly how broken the terrestrial build out has become. The most damning review of Earth's electrical grid ever written is a satellite with a GPU on it. And a twist inside a twist, the confession might actually work. The H100 is up there right now running Google's Gemma model in orbit as we speak. The radiation tests passed, the prototypes are funded. StarCloud raised $170 million this spring. This is simultaneously a slightly absurd workaround for problems we could fix with better policy and a genuine engineering frontier making real progress. Both things are true, and anyone who tells you it's only visionary or only ridiculous is selling you half the story. So here's what's knowable and what isn't. Knowable, the physics math is real, 8 times the solar yield, near constant sunlight, and chips that survive the radiation, and the economics have a published falsifiable threshold of about 200 per kilogram to orbit. Not knowable whether launch costs actually get there, radiators and reliability quietly eat the advantage, and whether any of this scales beyond demos. Even the optimists put real deployment a decade out, and the skeptics say if it happens at all, it unfolds over decades.